matching the schedule, and then we'll be finalizing it. Okay?
Okay.
Okay, Yatika. So at first we'll be discussing about triangles over here. Okay. Now, if you know, there is a rule for finding the area of the triangle, but before that, the rule which we are aware of for finding the area of the triangle, that rule is area of the triangle is equals to 1 by 2 times base times height, right? This rule we have used till now for finding the area of the triangle. But for using this rule, we need base, we need height. So if we already know we are having three categories of triangle. So the first category is scalene triangle, where all the sides are different. Second one is isosceles triangle. And third one is equilateral triangle. So this formula till now we have applied for the given triangle. That time it used to be given either the base or the height, like both used to be given, or if anything is missing, we have used the Pythagoras theorem also to find the unknown side, and then we have found the area of the triangle. So let's see whether this formula is applicable for scalene triangle, isosceles triangle, equilateral triangle, all the triangle or not. And if this formula is applicable for all the triangle, then why we are going to learn one more formula for just given by a scientist name is Heron. So Heron's formula, why we are going to learn that formula? If this is fulfilling the criteria, if this is working till now, what's the need of getting a new formula? So let's see. So isosceles triangle means two sides are same. Let me take the measurement. Suppose we are having an isosceles triangle where, just a moment, let me take the data first. Where this side is 5 centimeter, this side is 5 centimeter, and unequal side is 8 centimeter. This is an isosceles triangle. We'll be finding the area of this one just after a while. Now we are having equilateral triangle where all the sides are same. So that equilateral triangle is having the side 10 centimeter, 10 centimeter, 10 centimeter. Okay. Now scalene triangle. So we are having, let's say we are having the measurement of the scalene triangle as 40 centimeter, 24 centimeter, and 32 centimeter. These are the three types of triangle we are having. We'll be focusing on each of them one by one. So first we are going to focus on the second triangle, that is isosceles triangle. And we will be checking whether the upper formula, the area of the triangle formula, that is 1 by 2 into base into height, is that formula is applicable to find the area of this isosceles triangle or not. So according to the formula, what the formula says, its area is equals to 1 by 2 times base times height. What we need over here, base and height. Here, do we know base? Do we know height? So if we are taking 8 centimeter as a base, then what is the height? So height, we have to draw it by ourselves. Okay, if in a triangle height is not there, you have to draw a perpendicular. You have to draw altitude. And then you have to find the length of that altitude. How we will be finding the length of that altitude? Let's say this is the triangle ABC. And here we are having D. So we need to find AD. Is it possible to find AD over there? Yes, it's possible to find AD over here because there is a theorem also, or the concept of congruency. By the concept of congruency also, we will be just match up with that theorem. So let me tell you what that theorem is. If you are dropping a perpendicular in an isosceles triangle, that perpendicular will touch the midpoint of the other side. So here BD will be equals to DC. This is the theorem. From where exactly, like, out of like nowhere the theorem came. So this theorem exactly came from the concept of congruency. So if you know the concept of congruency, then we can say here we are taking triangle ABD, ABD and triangle ACD. These two triangle we are taking here. What exactly is same? Is same. AB is same as AC. 90° over here, 90° over there. So that also same. That angle ADB is equals to angle ADC. 90°, 90°, because we have dropped the perpendicular. We don't know about the side, whether the side is getting cutted in equal part or what. That we don't know. Still we don't know about this one. Okay. We are trying to prove both the triangle as a congruent triangle. Now AD side is common in both the triangle. And if you will look carefully, you will find that by RHS congruency, both the triangles are congruent with each other. Okay, so by RHS congruency, both the triangles are congruent with each other. And since both the triangles are congruent with each other, we can say from here, now from here we can conclude that this BD side and CD side, this BD and CD are same. Okay, since both the triangles are congruent with each other. That means the side BC is getting cutted in two equal parts. Why BD and CD are same? According to the congruency, it's same by CPCT. And that concept only I am telling you in a theorem, that whenever you will be dropping a perpendicular, that perpendicular will be cutting the other side in two equal parts. Okay, so here BD will be equals to CD. So if total is 8 centimeter, this will be 4 centimeter, this will be 4 centimeter. Why we are doing so? So that we can find the length of the perpendicular AD by Pythagoras theorem. We will be taking one of the triangle, either the left one or the right one, and we will be finding the length of the perpendicular AD. Okay, so in triangle ADC, here we know DC is 4, AC is 5. We have to find AD. We know AC square will be equals to CD square plus AC square in triangle ADC. This was just a part of the theorem. You don't have to do that. From where the theorem came, that's what I am saying. That if you will be dropping a perpendicular in an isosceles triangle, that perpendicular will work as a perpendicular bisector. Okay. Now from here, AC is 5, CD is 4. Okay, AC is 5. Why I have written AC 2 times? Why nobody is saying anything? I am writing it by mistakenly. I have written AC over here, AC over here. But nobody told me not to write that. So AC square, hypotenuse square is equals to CD square plus AD square. No? Are you getting it? Are you getting?
Yes, ma'am.
Why? Yeah. Why we are finding AD? So that we can find the area of the triangle, that is base into height. Height is not there. So we are totally focusing on finding the height. Okay. So AC is 5 square. CD is 4 square. AD we wanna find. So that will be AD square is equals to 25 minus 16. That means 9. And AD we are having over here as 3. Now what we want to do, we want to find the area of the triangle. So let's take base into height. Here we have written the area formula. Here only I am going to write 1 by 2. Base is total 8 and height on that AD is the height, that is now only we found 3. Is it possible to find the area? Yes, it's possible. Can you see it?
Yes, ma'am.
When we were having isosceles triangle, when only the measurement of all the 3 sides were given, then we have found the area. Meanwhile, we have used one theorem that whenever we will be dropping a perpendicular, that perpendicular will bisect the other side. So that theorem we have used, and the proof of that theorem also I have shown you, that why, from where this theorem came out. Okay. Now, each and every time directly we will be using this theorem. Now let's go to equilateral triangle. Is it possible to find the area of this equilateral triangle by using the above formula? So the above formula says 1 by 2 into base into height. What is the base over here? If this is PQR, then we can say QR is the base. And what is the height over here? Height we don't have. So we have to drop the height like this. And we can say height is PT. So PT is the height. Now, do we know QR? Yes, we do. Do we know PT height? No, we don't know PT. Here also, that formula will be applicable. That whenever we are dropping a perpendicular, it will bisect the other side. So this theorem is applicable for which triangle? This theorem is only applicable for isosceles triangle and equilateral triangle, because that time only you will be able to prove congruency. Okay.
Okay, ma'am.
So that this theorem is only applicable for isosceles and equilateral. Here also we will be able to prove congruency, because this side is equals to this side. There is a common side in between. Here we are having 90 degree, there we are having 90 degree. So here also we will be able to prove congruency, and the theorem is applicable. That is, side QR will get cutted into half part. So if this is total is 10 centimeter, this will be 5 centimeter and this will be 5 centimeter. Okay. Now again, with the help of Pythagoras theorem, we will be able to find the height PT. Okay. So if we are taking any one of the triangle, that is triangle PQT, right angle triangle PQT, then we can say hypotenuse square, that means PQ square, is equals to base square, that is QT square, plus PT square. From here, PT we will be able to find. Let's find it. PQ is 10. QT is 5 and PT square I am writing as it is. PT square will be 10 square minus 5 square, that means 100, minus 25, that means 75. Is it so? Now PT will be under root 75. Let's use it as it is, or you can also take it out from the root sign. Like whatever is possible, let's take it out from the root sign. So 15, 5 times 75. So 5 into 3 into 5. 15, 5 times 75. Here I can see 5 is in pair, so I can write it as 5 root 3. Okay. So let's put the value of PT. We have got PT as a 5 root 3. We are having QR. QR is just one of the side of equilateral triangle 10. And this is 1 by 2. So here also I can see we can find the area of the triangle just by using the older formula. Can you see it too?
Yes.
Everyone?
Yes.
Yes,
Right?
ma'am.
Now, in isosceles triangle, we were able. In equilateral triangle also it's possible. Is it possible in scalene triangle also? Let's check it. So in a scalene triangle, if you will be dropping a perpendicular like this, and you are going to use the area formula 1 by 2 into base into height. Here you can't say. Here if the name of the triangle is MNO, and here if you are having the point T, then you cannot say here that NT is equals to TO. This is not possible over here. these two are not equal over here. Why? Because there is a theorem which says whenever you will be dropping a perpendicular in isosceles triangle or equilateral triangle, that perpendicular will act as a perpendicular bisector of the other side. But here, when you are dropping a perpendicular, that perpendicular will not work as a perpendicular bisector. Why? Because once you will go and you will try to prove this triangle, that triangle as a congruent, that is not possible over here. You just check it whether these two triangles are congruent or not. I'm talking about this triangle and this triangle. I'm talking about these two triangles. Is it possible to prove both of them as a congruent? We are not sure. What we are having equal in both the triangle, only the common side is same in both the triangle. And apart from that, 90 degree is here, 90 degrees there. But after that, what else is same? Because we need three information. Nothing else is same. Can you see?
Yes, ma'am.
So it's not possible to prove both as a congruent, and hence the theorem is not valid over here. Okay, and it is not possible to find the height over here. And since it is not possible to find the height over here, there comes a hero formula which says that there is a formula which is applicable for this scalene triangle, isosceles triangle, equilateral triangle, any triangle. So a scientist has given one magical formula, and that formula will be helping us to find any triangle's area. Not only for scalene, for any triangle. Yes, scalene triangle area was not possible to find it. Till now, we have used the formula 1 by 2 into base into height. Their height used to be given. Okay, if scalene triangle was the case, then height used to be given in the question itself. But when height is not known, it is not possible to find it by using the measurement of the three sides. So the Heron's formula is let me check any other part is there before the introduction of this formula. No. Yeah, you just need to understand a little bit about the triangle and the height of the triangle. Now the formula says this is equals to S minus A, S minus B, S minus C. Now this S is equals to A plus B plus C by 2. What is A, B, C? Where A, B, C are sides of a triangle. So if you know A, B, C, easily you can find S. Easily you can substitute everything in the formula and you will be getting the area of a triangle. Okay. For calculating area of any triangle. So let's check whatever area we have found for equilateral triangle and isosceles triangle by using the older formula. That area is matching up with this. Like, is it, if we are going to apply the new formula, are we going to get the same area? Because we are talking about one triangle, the isosceles triangle, previous one, this triangle. Okay, this one. So whatever method you are applying, you must get the same area, right? So let's check it by new area formula. So the new area formula says if the sides are 5, 5, 8, let me draw it again. The sides were 5, 5, 8. And the new area formula says first find S. S means A plus B plus C by 2. Addition of all by 2. So 8 plus 5 by 2. 8, 5, 13, 13, 5, 13, 5, 18, right? By 2, that means 6 we are get to 9 we are getting, right? So here we got S as a 9. Now what the formula says, find S and then put it in the formula. S minus A, S minus B, S minus C. So under root S, that is 9. 9 minus 8, 9 minus 5, 9 minus 5. This is what the formula says, the new area formula. Let's check it. Under root 9, 9 minus 8 is 1, 9 minus 5 is 4, and 9 minus 5 again is 4. As we can see, this 9 can be taken out from the root sign. This is 3. This 4 can be taken out. This is 2. And this 4 can be taken out. This is 2. So what we got? 3, 2 times 6, 2 times 12. 12 centimeter square. Let's check it above. Have we got 12 only? So that time we have not done the calculation. Let's do the calculation. So 2, 4 times 8. Can you see? Here also we have got 12 only. Can you see?
Yes, ma'am.
So older formula or new formula, we are landing on the same area because we are talking about the same triangle. What I said, this new formula will be helping us to find any triangle's area, be it a scalene, be it a isosceles, be it a equilateral. Let's check the equilateral triangle area formula area with the help of new formula, our brand new formula, the Heron's formula. So let me check. The new triangle was 10 10 10. Okay, the new triangle side was new triangle, not equilateral triangle. The third one was 10 10 10, and the name was PQR. We are going to find the area by using new formula. New formula says first find S. S is equals to sum of all the side, that is 10 plus 10 plus 10 by 2. That is 30 by 2. That is 15. Now area will be under root S, S minus A, S minus B, S minus C. So under root 15, 15 minus 10, again 15 minus 10, and again 15 minus 10. So we will be having 15 into 5 into 5 into 5. Here let's see how many pairs are there. If we'll be breaking 15 also, we'll be getting 5 into 3. And here 5, 5, 5. One pair, the second pair, and 3 got stuck inside the root sign. So we got 5 into 5, root 3. That means 25 root 3. Let's check. Previously, we were having 25 root 3 as an area or not. Let's check. This rectangular box, can you see?
Yes, ma'am.
Here we need to do the calculation to check it. Let's do the calculation. 2, 5 times 10. Can you see it's 25 root 3 only?
Yes, ma'am.
And now also we have got 25 root 3 only. So yes, this magical formula is helping us to find any triangle area. We must have all the side in hand. That's it. That is the criteria. If we are having all the side in hand, we will be using this magical formula. If we are having height and base in hand, we can use the older formula. Okay. Now the question is, what will be the area of a scalene triangle, which was not possible to find by the previous rule. So let's find it. 32, 24 and 40 was there, no? 32, 24 and 40. Again, the same formula, S is equals to A plus B plus C by 2. That is 4, 5, 6. 3, 2, 5, 4, 9, 96 over 2. That is 2, 4 times 8, 48. Now, area will be under root S, S minus A, S minus B, S minus C. So, under root 48, 48 minus 32, 48 minus 24, and 48 minus 40. Till now, you must have understood how to use this formula, right? Everybody, is it clear so far? I'm not going to do the calculation because I believe you will be able to do the calculation by yourself.
Yes.
Okay. So is it clear so far? how to use this formula?
Yes, ma'am.
Okay, let's move to the questions. Okay, the exact actual question from the exercise. So this is the formula we are having, and you can see this formula will be the rescue when you don't have height in hand. Okay, when you are having all the three sides, directly you can use this formula. Now exercise 12.1. Here the first question says a traffic signal board indicating school ahead is an equilateral triangle. There is a traffic signal board indicating a school ahead. The traffic signal board is in form of equilateral triangle where the sides are A, A, A. That's it. Find the area of the signal board using Heron's formula if the perimeter is 180. Perimeter of this equilateral triangle is given as 180 centimeter. Now you need to understand what is perimeter and what is area. Whenever we are just walking along the boundary of any shape, just let's say I'm going to walk along the boundary. I'm starting from here, and can you see the green color marker? I am just starting and moving along the boundary of this shape. I am walking, 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 and then walking and just covering the one complete revolution. That's called perimeter of this triangle. So how much distance I have covered? I have covered the distance A, then again A, then again A. That means A plus A plus A. This is the total distance I have covered, and this is called the perimeter of this triangle. What is area of this triangle? So whenever we have to find the perimeter, we will be just taking all the side and we will be adding them together. Suppose I am walking on this type of road. First gone straight, then turn this side, then again this way, then again this way, then again this way I am going, then this way, then this way, like this, like this, like this, and this. This way I am just walking. Okay. So if I am saying this is 5 centimeter, this is 2 centimeter, this is 1 centimeter, this is again 2 centimeter, this is 5, this is 2, this is 8, this is 7, this is 1, this is 4, this is again 5, and this is 2. So what is the perimeter of this shape? Perimeter means what? Even this shape looks so weird and random, but you will be able to find the perimeter of this shape just by adding all the sides, because you are walking along the boundary only. Okay, so perimeter of this shape will be, perimeter of this random shape will be 5 plus 2 plus 1 plus 2 plus 5 plus 2 plus 8 plus 7 plus 1 plus 4 plus 5 plus 2. This is how we find the perimeter of any shape. Okay, so now we'll be focusing on area of this triangle. What is the area of this triangle? So when we are talking about if there is a triangle, and if we are talking about the area of the triangle, that means we are covering this part. This part, if I am going to paint the total part, the middle one, that means I am working on the area of this triangle. I am walking. I'm not saying I'm walking, I'm saying I'm working in the area of the triangle. I'm painting the area of the triangle. This is called the area of the triangle. Okay, so this is sky is the area, but that green on the left, that is the perimeter. So you need to understand what the difference between area and perimeter. In our question number 1, perimeter of the shape is given as 180. That means a plus a plus a, that is 3a is given as 180. 3a is given as 180. From here we will be getting the side of an equilateral triangle, that is a, and that will be 180 by 3. That is 60 centimeter. We got the side. Now the magical formula to find the area of the shape, the magical formula is under root s, s minus a, s minus b, s minus c. So here, what is S? S is A plus B plus C by 2. So what is A plus B plus C? That is 180. Okay, you can check it. If 60 plus 60 plus 60, because each and every side is 60 centimeter, it's an equilateral triangle written in the question itself, by 2. That means 180 by 2. That means 90. So S we got, this is the formula to find S. First, with the help of the perimeter formula, we found the side. And then once we are having side in hand, we know we can do everything. We can find S, we can put everything in the formula. So now we are having S as a 90. S minus A, 90 minus A is 60. Again 90 minus B is also 60. 90 minus C is also 60, because we are dealing with an equilateral triangle. Is it clear to everyone?
Yes, ma'am.
So this is how we will be finding the area. Now this is square root calculation I am leaving for you to just check the pairs and take it out from the root sign. That I am leaving for you. You have to check it. And then you have to find the final answer by yourself. Can we move ahead?
Yes, ma'am.
Let's take the next question. Number 2. The triangular side of a wall of a flyover. A flyover is drawn already in your book. Okay. That flyover is having a triangular side of wall that has been used for advertisement. The side of a wall are given. Let me take only the side of a wall. This type of wall is there. Here the sides are given: 120 meter, 22 meter, and this is 122 meter. Advertisement yield an earning of this advertisement yield an earning of rupees 5,000 per meter square per year. A company hired one of its 3 wall for 3 months. So company is hiring one wall for 3 months. This is the charge which will be applicable. That 5,000 rupees for 1 meter square area for 1 year. Okay, we want the wall for 3 months. How much rent we need to pay? Okay, so whatever hoardings and everything you see on the buildings and on the building or anywhere, they pay the price for that. They pay, like they pay the price that we need our company name on that building. So they need to pay the price for that advertisement. Similarly, if they want an advertisement on the TV, they need to pay the price for that, right? If you are just seeing a Pepsi ad, a cold drink ad, or a Colgate ad, or any detergent or anything ad on the TV, that means that company has paid the price, right? Then only we are seeing the advertisement. Similarly, on the wall also, if they will go and paste the picture, they have to pay the price. Now, how the pricing is decided? Here, the pricing is given in our question, that the pricing is rupees 5,000 if for 1 meter square area for 1 year. So first we need to find the area of the wall, because the total wall, this one wall is used, right? So how much meter square is the area, that we need to find, because 5,000 rupees is for 1 meter square. So let's find exactly what is the area of our wall. So area of this triangle, again, Heron's formula. So Heron formula says area formula is S minus A, S minus B, S minus C. What is S over here? S is nothing but A plus B plus C by 2. So let's find S. S is 122. plus 22 plus 120 by 2. That is 224, 224, 5, 6, 1, 2. Is it correct? Please check it. Is it okay? Or are we missing something?
Yes, ma'am, it's okay.
1, 3, 2. This is S. Let's find area. 132 S minus A. 132 minus A. If your question is what's A, what's B, what's C, you can take any one of the side as a A, other one as a B, other one as a C. So 132 minus 120. 132 minus 22 and 132 minus 122. If we'll be doing this, we'll be having 132 times 132 minus 120, 12. Here 0, 1. Here 132 minus 122, 0, 1. Okay, here I'm missing something. Here it will be 110. 0, 1 and 1 is remaining. Yeah. Is it correct so far? Please check. Is it okay?
Yes, ma'am.
Now we'll be taking out from the root sign. So as I said to you, how you will be taking out from the root sign, please don't do the multiplication. Otherwise, you are going to make it more complicated. We need to break it as much as possible. It's already in broken form. So please don't do the multiplication and make it a larger number. So what we are going to do, 132 means, I believe it's 11 into something. 11 into 12. How you will get it's 11 into 12? You can do the factorization. 132 factorization you can do, and you can check it's 11 into 12. So again 12 into 110, I'm going to write 11 into 10 into 10. So this pair and this 11 and 11 is in pair. Can you see? You can break it in a smaller number also according to your convenience level. Okay, this is how I am doing it, but you don't have to copy it like this. Only the concept I am showing you, that you need to break it. Don't do the multiplication of all of them together. Okay, now how you are breaking, that's completely up to you. You can break this 12 as a 4 into 3. You can break 12 as a 2 into 2 into 3. It's completely up to you. Okay, you can break this 10 as a 5 into 2. Still your answer, my answer will be same. So I have broken it like 11 into 12 into 10. Now we got 11 into 12. We know it's 132 and this 0. This is the area, this much meter square we got. And the price for 1 meter square is rupees 5,000 for 1 year. Do we need for 1 year? No, we need for 3 months only. So let's customize the price at first. Okay. So it's 1 year price is 5,000 rupees. So that means 12 months price is 5,000 rupees. Now 1 month price will be 5,000 divided by 12, right? If 12 oranges cost is 5,000 rupees, then 1 orange cost will be 5,000 by 12. Yes or no?
Yes, ma'am.
Similarly, now 3 month cost we have to find, because we are going to take this wall for 3 months. So 3 month cost will be 5,000 by 12 into 3. Okay, let's cancel them out. 4 1 times 4, 4 2 times 8, 4 5 times 20. We are getting 1250 rupees for 3 months. Okay. This is for 1 meter square. This is the price for 1 meter square, and we have to find the price for this much meter square, 1320 meter square. So for 1 meter square, if the price is 1250, then for this much meter square, it will be 1320 into 1250. Okay. So for 1 meter square, price is 1250 rupees. Therefore, how much meter square we are having? 1320 meter square we are having. For this much, it will be this into that. Are you getting it? This much rupees will be having. Are you getting it?
Yes, ma'am.
Everyone, is it clear? Is it clear to all of you? So, what was the question? Let's do the summarization and then we'll be moving to the next question. So the question, if that is not clear, was we are hiring a wall for doing the advertisement. Since we are taking a wall, we are using one of the wall for advertisement. Obviously, we need to pay for that. What is the price? The price is 5,000 rupees for 1 meter square for 1 year. But we need this wall for 3 months only. We will be doing the advertisement for 3 months only, because our company has decided that 3 months will be well enough, so that all the people, whoever is going every day to from that area, they will notice it. So 3 months is, it's of more than enough. So that's why we are hiring it. Like, we are not hiring, we'll say we are just going to use that wall for 3 months only. Okay. So we need to find the price for, what is the price for 3 month. 1 year price is given, 3 month price we have to find. That we have found, we have kept it aside. That price is given as this much price for 1 meter square. So we also need to check what is the area of the wall that we are going to use. 1 meter square there, that is the standard price they have given. Maybe they are having a lot of building in that locality and everything, so they are having their standard price, that 1 meter square price is this one. Now if you are using that wall, this wall, that building, whatever you are using, 1 meter square price is this one. You just calculate your advertisement area and pay the price. So we have calculated the area according to our triangle, and then we have calculated the price. Is it clear to each and every one?
Yes, ma'am.
Okay, let's move to the next question. So the next question is, there is a slide in a park. One of its side wall has been painted in some color with a message. If the side of a wall are this. Side of a wall are given as 15 meter, 11 meter, whatever is the whole story, we will be focusing on what exactly we have to find here. So here side of the wall is given, find the area. It's very simple, right? Side is given, we have to find the area. By Heron's formula, when the side is given, we can use Heron's formula to find the area, that is S minus A, S minus B, S minus C. S we can easily find by doing 15 plus 11 plus 6, A plus B plus C by 2. That will give S. Now we can take this as a, this as a B, this as a C, and we can find the area. So it's very simple, right? Right? Everyone, I'm leaving this for you. Please do it, because simply we just have to go ahead and we have to put everything in the formula, and then we have to calculate the square root. Number 4, find the area of a triangle, two sides of which are this and perimeter. So we are having a triangle. whose one of the side is given as 18, another side is given as 10, and third side is not given, but perimeter is given. Perimeter is given as 42 centimeter. Now only I was explaining you what exactly is the perimeter, just the sum of all the side. So perimeter is 18 plus 10, and let's say that question mark side is x centimeter. So plus x is equals to 42. From here we'll be getting the value of x, right? Yes or no?
Yes, ma'am.
And once we are having x in hand, we have to find the area of this triangle. X means once we are having